Hello there. I have a video today about something that I've been trying to get in one form or another for years now. I've clearly been after printing typewriters for a long time. I looked at the Smith Corona memory writer, the Brother EP20, the Xerox memory writer, and I also have an IBM Wheel Printer Series 2 that's sitting around here somewhere. They're all very cool, but none of them can do one of the other features that I've been after: acting as a serial printing terminal. But today, I finally managed to get my hands on one, and it's down here because it's huge. This is a digital DECWriter 2, or an LA36. The LA35 is basically the same thing, but sans keyboard to work just as a printer. This is a hard copy paper printing terminal that I believe hopefully will use RS-232C. But we'll take a look at that in a second. Now, like I said, I've been after something like this in one form or another for years. The closest I've got for something like this that has actually worked was a Brother EP22 that I picked up recently. I also have a pair of TI Silent 700s, but they don't work, and I've kind of given up on that because they all seem like they're just garbage. So this is something that I'm really hoping is going to work out. Now, this particular example is in really good cosmetic condition, so I'm optimistic there. It came from a government surplus, and I don't think it was used too much based on how little surface wear I'm seeing. Inside of it looks pretty good. I've already opened it up just to make sure that this video looked feasible, but inside I found some massive capacitors we're going to need to reform. I also found some smaller capacitors that are a little suspicious. They are the Sprague axial ones, that one of which was shorted on one of the Micronova cards. So we have some work ahead of us before we can put power to this thing and find out if it works. Okay, I want to start by giving you a little walk around tour here. Because this thing is massive and it's really hard to get the cameras to show everything I want, and the way that it goes together is not going to be very convenient to film. Now, this thing may not go together quite the way you think. The chassis up top is shockingly thin, and that's because it's mostly empty. Down here, you can see a fuse holder because all of the electronics are actually in there. The top side is mechanical only for the most part. So the typewriter functional components can never be removed from the base, which makes moving this thing around really, really fun. Now, around back here is where you actually access everything. There is a panel here with screws up there that we can take off, and then this thing folds down. So we'll be doing that in a moment. But again, that's big and there's not a lot you can see. Now, conveying the size of this thing is a little difficult, so let me use one ISM unit of a Model M here, and you can see how it just dwarfs the Model M. So, yeah, it's a little difficult to work around this thing here, but we'll figure it out. Before I stop being mobile, I do want to show you this, though. This is the data cable coming off of this thing. So when I question its RS-232C-ness, and this is part of it. I'm hoping that this just went to something weird. I don't know what, but yeah, this is what the current data cable is. So I'm either going to have to modify this, which looks like I won't have been the first person to do, or make a new cable, but I don't think I have the connector for the other end of this. Now, what's kind of funny about this connector is I thought I had the complementary one here for a moment because I've been working on a project to build a Data General Dasher keyboard adapter, but the thing is, these are actually very differently sized. So this one doesn't fit in here, despite it using a very similar pin grid type latching connector. So yeah, I have nothing that can connect to that. Again, if anyone in like the comments here knows what this originally went to, I would love to know, but yeah, I'm probably going to end up, let's actually just go ahead and do this, peeling off this tape and making sure that this was hacked together. Yeah, I'm seeing pretty clear evidence that I'm not going to feel too bad about undoing this cable. So yeah, we'll probably remove this connector and put a standard DB25 or DE9 shell on here just to make this thing more usable. Wow, this is... yeah, this is really hairy no matter what. Yeah, we're definitely redoing this. All right, now there's several things that we can work on for this, but I want to start by getting this open so that we can get the capacitors out and start reforming them while we look at some other things. Now, the two Phillips screws that are back here are actually retained, which is super duper cool. Overall, this thing seems pretty well made. The only other piece of DEC hardware I have is the DEC Talk, so this is all new for me. I am pretty obviously a data general man, so this is all new territory. All right, there are little plastic latches there, and there is the inside of the LA36. Now I call this the LA36 because if we look here, we can see a model number LA36-DE. There are different variants and configurations of the DECWriter 2, and that's what makes it different between the LA36, the LA35, and then the different sub-configurations. And this is where the information I've been able to find about this thing starts to taper off, because I really don't know what I'm looking at inside of here as far as which exact version this is. But let's go over what we can determine is going on in here from just what we can see. So the main logic board is down here. This is going to handle the incoming serial data through that connector, send it out to the motor control board here, also solenoid control, through two connectors. Now I believe this connector is carrying the stepper motor control signals, and this one is carrying the head solenoid signals. The head solenoids are gonna look kinda awesome, I think, but I haven't actually gotten a good chance to take a look at them yet because we're gonna need to pop this top cover off first. Now, this board appears to go all the way up behind this giant heatsink. So I think this is one huge PCB there, so that there is heat sinking for the RCA TO2 transistors up there. They appear to be 3069s. Well, there's a 3068, 3069. Yeah, so there's a couple of variants of transistors up there. And that's mostly it, other than another ferro-resonant transformer down here with a motor start cap, which after the Data General 6039 floppy drives I've determined is not something that I can reform or need to worry about reforming. Just the oil-filled caps in general appear to be good, so I don't need to worry about that one, thankfully. The ones I do need to worry about are down here. So let's disconnect the head solenoid, I presume, connector here. A digital branded ribbon cable there. All right, and that will give us access to this. And this is why I'm using the ESD screwdriver here so that I can safely work on this in case these caps are charged and I don't realize it. Now, something I have already seen from moving this thing around is that, unfortunately, these capacitors are all held down with zip ties. So it's not really possible to remove them non-destructively. So I think I'm going to try and reform them in place, which is going to complicate this. Everything here at least looks very similar to the Data General stuff I've been working on. It's a Sanguamo 40 volt, 14,000 microfarad cap. That's a bigger one right there. Oh boy. We got a 37,000 microfarad 15 volt cap there. And then unfortunately, I don't see the label on Monstroso there, so we're gonna have to figure something out with that. There are some schematics available, so I might be able to find it on those. But yeah, I would like to, know what that is so that I can apply the correct voltage to it for reforming, because yeah, that's the one that needs it the most. Now, looking at how this goes together, all of these capacitors go to this connector right here. So if I disconnect this, I think I will isolate all of the capacitors from the rest of the circuit. And other than the negative terminals of these two, I think they will all be isolated from each other. So I think it'll be pretty easy to do this, and I may not even need to remove the screw terminals. I can just clip onto these to do the reforming. Okay, I certainly wasn't expecting a, 33,060 volt cap? Yeah, that's a monster there. I was not anticipating that. So let's go ahead and get this connector off. All I did was put blue tape on here so that I know which side it goes to. It's probably keyed, but I wanted to do that just in case. Yeah, this is a keyed compared to the other ones as well. We can see the plastic fill plug that they have installed. So yeah, it's pretty well designed. Okay, so these are now all separate from each other. I don't have to worry about potentially reforming multiple caps at once now. So we can work on getting that set up to start doing that now. All right, now I'll briefly demo the setup here. I have a capacitor connected to the output. It goes through a bunch of other stuff. There's a current limiting resistor and a bunch of connectors. I'm using a 3441A here and the power supply there. And this is my software that allows me to control everything from the beginning. So all I have to do here is check everything's set up correctly. I have a 1K resistor. I have my current minimum and maximums. I'm logging and I'm going to hit start reform, and it is going to start reforming that capacitor. So we'll get this graph, and if I change this data point to say 50 here and refresh the page, we should get some miniature charts over here. These are good for monitoring the reforming in process. Now I'm not going to bother showing the live process for this as we go through all of the capacitors, but I will show you the results for each capacitor. That way you can see what condition they're in. Generally, I will expect to see a rapid reform at the beginning where the capacitor is mostly good. Then it will start to taper off. So we're going to get a curve that goes up like that. All right, now before we get started here, I want to show you that these capacitors are all extremely discharged. So here I have my multimeter in voltage measurement. The plus side is on the right on all of these. And if I go in here and take a look at these, yeah, we're getting absolutely nothing on these. So yeah, these are fully discharged. So yeah, I want to make sure I go real slow on these. Now, before I start reforming these, I'm going to want to take this off while we're doing that. So I'm going to remove these two screws that are back here in advance. That way I don't have to get near the capacitors while they're reforming. Not that there's anything that's going to happen with them. Just don't want to risk bumping the cable while I'm doing this. Oh, wow. There must not be a lot of screws on there. Okay. All right, there we are. And this is 40 volts DC. All right, go to my setup, set my target voltage to 40, my resistor to 1000. I'm going to set my current maximum to 4 milliamps, actually. I'm going to set my current minimum 500. All right, here we go. Yeah, this is a good one to have reformed. I don't think I've ever seen one of these go this slow, this far down. All right, now there's one piece that I think wasn't included with this. There should be a clear plastic piece that goes over the paper here. Mine doesn't have that, but I've also seen it be missing in a bunch of them. Like this advertisement here doesn't show one at all. But without that, it's pretty easy. We can just lift this piece up and out. And we can't see a whole lot in this area. The only thing that's here are the two enormous spools of ribbon that are thankfully still here. Now this thing has definitely been used, but again, I don't think it's been used a lot or recently, especially not now that I'm seeing what those caps are doing. I'm really glad that those are in there because those are not universal typewriter 2-inch spools. So those are a little different. Now I'll get some tighter shots in here, but I want to remove this whole piece first because like I said, it's only a few bolts. Actually, there are bolts missing that should be on there. Ah, okay. So there are only 4 more left along the front here. I can see some standoffs that should be about here and on the sides. That's not a great sign, but let's get these off. Now, I have found, and some of them even came out while I was jiggling it around, a bunch of loose fasteners and things in here. That's a little concerning because, for one, I need to find all of those before we can power this thing up to make sure that nothing gets shorted. And 2, I don't know what they go to. Now, I don't know if the platen handle comes out easily. So what I'm going to do is I'm going to try and lift this over into the side. There we go. Oh, yeah. Oh, my gosh. Look at that incredible solenoid setup. Dude, that thing is ridiculous. So I assume these are each individual solenoids that go to the head, and I'm guessing it's only 7 dots. But yeah, that's so awesome. Now, Weirdly, I can't move this. I don't know if the stepper motor over here like locks or something when it's not in use, but this does not move at all. The belt looks like it's in really good shape though, which is nice. It even has a deck name and part number on it. That's hilarious. All right, now let's talk about a little bit of an elephant in the room with the keyboard. This is a stack pull high-tech switch keyboard, which if you've seen my videos on the HP86 are the bane of my existence. But so far, not a single one of these caps is sticking because what happens with these keys is they're made out of a tube that has a stem that goes down into it. And over time, that stem can shove down it farther and splay out the tube, causing it to crack, expand, and then stick when you push a key down. None of these seem to be exhibiting that though, thankfully. We can see there's some weird unevenness. Number 4 is higher than number 3. I could attempt to press it down to make it go farther down into the stem, but I could just as likely crack it, so we're not gonna mess with that. It's kind of a shame that these have that problem, because for being a linear switch, I really like how these feel. It's probably just because they're really heavy actuation force or something like that. But yeah, that's what this is. They're probably gonna work just fine. I don't think I've ever seen a stack pull high-tech switch keyboard have an issue, so at least it's not foam and foil. We don't have to worry about that. It's just the second worst kind of keyboard, if you ask me. Now, I don't really need to remove the keyboard, but I think I should just to be able to see more of what's underneath of here for the random loose parts that I keep finding. It's only 4 screws on the side, so it's not gonna be that bad anyway. Although it looks like it is slots, so aligning that to the top is gonna suck, but oh well, I think it should be done. Don't know what the cable situation is for this. It is very and a lot. Okay. Oh, these are... Okay. Weird. Why? That complicates things. All right. I don't think I want to move it too much. I just want to look underneath. Make sure nothing looks out of place. I mean, there's spider webs, but that's it. A May 1976 stamp date on the PCB here, and high-tech branding on this PCB. Yeah, outside of that, I don't want to move this around too much. These cables are very stiff. I don't want them to crack in the insulation or anything, so we're just going to put this back, I suppose. You know what? I'll leave it loose so I have some room to get my hands in places. Because there's some stuff like down in there I can't reach. All right, getting in here a little more, this is kind of interesting. There's no soft backs. That just lifts off? Is that... Ooh, that is supposed to have plastic retention snaps. Okay. That explains why this has been missing on all of these that I've seen online, though. I'm going to set this aside. Probably try and re-glue that snap on. There's nothing I can do about the other side. Anyway, the reason I was getting so tight up in here is this is the backstop, apparently, for the printing mechanism. It's just a aluminum bar. Usually this is like a soft piece or something here so that the pins don't like mushroom. That's weird, man. So I assume the impression strength here is going to be pretty critical to make sure that you don't just destroy your print head. Hopefully that hasn't happened to this one, because I see it says digital on there, so that's not going to be easy to replace. There's not too much to see up here, but there is this part. So this is a Litton brand stepper motor. That's kind of cool. But this is a single piece spindle gear for the belt. And I can see some cracking on there, likely from contraction of the plastic over time. I'm hoping that's not a problem. But again, I can't move this. So something somewhere is holding this in place. I don't know where. I'm hoping inside of this there's maybe like a peg or something that is locking it, or maybe the step strength of the magnets is just insanely high. I don't know, but I'm hoping it's not a problem somewhere. One other thing I would like to call out that is kind of a disappointment. This here is a speaker for the bell character. It's not an actual bell. I mean, come on, how awesome would it have been if there was an actual bell in here? Okay, I can't stop calling things out because this thing is awesome, man. But this is something that I had noticed online. So every picture I've seen of one of these plates that I believe are just like polished steel or something, on most of these, those seem to be rusted like crazy. This being Arizona, so it's very dry to begin with. And the fact that this was probably kept in a warehouse for the last 40 years means that these are in fantastic shape. And that also gives me hope that the rest of it's going to be in really good shape as well. So seeing those be so nice and shiny is one of the reasons that I bought this thing. Couple of other things over here. We have the motor for the platen control, and we have a lid close detection sensor too, which is a giant switch over there. Another thing here, this is the paper sprocket, and it's a regular belt that has plastic pieces that hold the paper in. I've seen some of these where it's like a flex PCB that has little knobs like connected to it somehow. This seems a lot more resilient, other than the fact that the rubber belt could decay and fail, but I kind of really like that solution, so I'm optimistic about those. All right, I think the last thing I have to show here is this sticker, which contains some serial number and configuration info, I believe, for this unit. I couldn't quite figure out how to decipher this, but I think there might be information in the manual on it. All right, well, it's kind of it for what I wanted to look at up here. I didn't think that this capacitor was going to take this long to reform. We are 20 minutes into it, and it's not even a quarter of the way done, and it only gets slower as it goes farther along. So I'm a little nervous that these caps aren't going to pass. But I'm going to let this go, and we'll see what happens. Yeah, this is... man, I may end up giving in and raising the maximum current level. But we'll see. I don't know. I want to give it a little bit more time and see how it behaves, because this doesn't seem right to me. This is where this project started to take a turn on me. I initially thought I could knock this out in 3 days. Well, everything you've seen so far was filmed over 3 weeks ago now. My concerns about the capacitors were warranted, and I ended up spending a week on just reforming them. Slowly. The Sanguamo caps were very degraded, and I think make for an interesting case study because they exhibited a behavior I had not observed before. I'm going to assume here that you've watched my video on how the capacitor reforming process chemically works, and if you comment on this video trying to debate it, I'm just going to reply to you with a clown emoji. Now, I described that ideal curve shape that I'm looking for, and some of the caps did do that. This is what I expect a healthy reformed cap to look like on the first pass, and rerunning the same process on the cap after should have a flat line as it no longer uses energy to reform the dielectric. But some of the caps got to a point where they started to go backwards, and the lower voltage means an increase in current draw. They always recovered and continued though. I observed this happening 3 times on 2 caps. My best guess is that a portion of the dielectric was weak, and as the voltage raised, it started to fail. And as it thinned, it started to consume more of the electrolytic fluid to rebuild it, which was a very slow process that also generates heat and pressure. I run my cap reforming with a low current, and it's possible that if I'd set this up more aggressively, that it could have caused a rupture. And without reforming, this almost certainly would have blown in the full circuit. This is the first time I have observed what I believe to be a capacitor being definitively recovered with reforming. Every capacitor I reform, I always run through the process twice to see how its performance changes, and they always improve. And even that can be helpful for second-order effects, like not overstressing a power supply by reforming in circuit rapidly. But I've never seen something as drastic as this that likely avoided a catastrophic failure. I mentioned it was specifically the Sanguamo caps, though, that were degraded. The huge 60-volt cap was made by Mallory, and it reformed probably 4 times faster than the Sanguamos did on its first pass, while also going to double the voltage. It's probably down to the chemical makeup of the electrolyte between brands, or another factor, but this was the widest array of responses to reforming I have ever seen in a single device. With all the caps reformed, though, I was ready to turn it on and find out what condition this thing was really in. All right, I think I'm on day 6 or something, and all of the caps are reformed. Now, the 15-volt cap, the third one in of the white ones, the Sangamos, I'm a little concerned about, but they all reformed mostly fine. So I'm going to try and turn this on. Now, this is all I'm going to do for right now. I just want to see if the mechanism moves, because apparently this also is a 20 milliamp current loop version of this thing. It was pointed out to me by one of my supporters that it's lacking an adapter board that would be internally mounted that converts this output connector to be proper RS-232. This is apparently TTL UART effectively right now, which might be usable with a level shifter, but we'll look at that later. For right now, I just want to see if it turns on and functions roughly as a printer typewriter right now. All right, let's give it power. It's active, turning it on. All right, those temps all look pretty good. Paper out. I don't know how to use this. Was unsure if there would be a local mode or something. Well, there's some logic working because it knows whether or not the paper out is working. However, the alt care set does not appear to be doing anything. Don't know if pushing anything on the baud rate buttons is doing anything. It is entirely possible this has no way of just working as a local typewriter. I don't know if that would be a feature that people would want. That would be effectively, I mean, it's got to be able to do like half duplex. So yeah, those are kind of expected up there. I'm seeing 115, that's not too bad. Down here, we're at 158. Again, though, those are power resistors, so it's not unexpected. Everything down here looks fantastic. Chips are a little hot, but they're like 88. Yeah, caps are all cold compared to everything else. Yeah, I don't know. Anything up here looking wonky? Oh, hello. That's not good. 118, 116. Okay, we might have a jammed pin. Wasn't paying attention to that. That could be a problem. I might want to try disconnecting the ribbon cable, if I can, and debugging it.
The other notable thing is that the print carriage didn't move. Typically printers like this will home the head on startup, and this one just sat there.
But I'm going to go ahead and call that for right now. I will come back to this in this video, but today that was all I wanted to do, just make sure it would power up. I kind of learned what I needed to learn, and that it's not just going to turn on and work.
At this point, it was pretty clear that this project wasn't going to go smoothly, and I turned my attention elsewhere for a bit. And when I came back to this, I decided to stream working on this, which was probably for the best, because I ended up putting a lot more work into it, and needed some help to figure out everything that was wrong. First, I turned my attention to the solenoid, trying to rasp the pin free. This did nothing, so I disconnected the head and the back and started looking at the whole carriage not moving. I needed to isolate where the problem was. The belt connects to the stepper, the carriage itself, and another gear that drives the ribbon advance. Any one of those could be the cause of the jamming. Thankfully, the belt is only spring tensioned and I was able to remove it easily. The stepper was able to spin freely, as well as the ribbon gear, but the carriage itself still wouldn't move. So that meant it itself was stuck on something. I attempted to remove one of the rails it mounts on, thinking I could clean it, but it turns out you would have to disassemble the entire thing to do that because they're countersunk into the two sidewalls. So I was gonna have to figure this out in situ. I couldn't see anything obstructing it. It would move just slightly if I wiggled it, and it wasn't the shipping lock because that's just a long gone zip tie that you cut off according to the manual. I was running out of ideas and decided to just try the worst one and yanked on it, which worked. It slid perfectly after that and it never got stuck again. I didn't see anything on the rail where it was, so I can only guess that the metals interacted after years of sitting against each other. But whatever the cause, that was one problem down. But after putting the belt back, it still didn't move. My next assumption was that the logic could be getting held up, forcing the pin to be stuck and preventing the rest of the initialization. So I started to look at how the pins are driven and working my way back to the logic. The majority of my time troubleshooting this machine was spent on this problem, and I really can't even keep it all straight in my head, so let me just go over some of the big details. All of the voltage rails were always fine, so it wasn't a power issue and the caps are holding up well. We found that the transistors that drive the stuck pin were active, but it didn't seem to be a strong activation. Then I chased the signals back up to the logic board and found that that specific pin was being activated by the character ROMs. But this was a complete red herring and a total coincidence. The printer output was disabled at this point in the logic, and even though the front end of the solenoid circuit was receiving the activation signal, the signal it should pass was shut off. This was driving me crazy, because it was becoming apparent that this was an analog domain issue, not a digital one. As a break, my viewers and I were looking through the motor control schematics for the carriage and was reminded of the painfully obvious fuse that I pointed out at the start of this video.
Well, that was F2 on... What's that fuse?
I hadn't looked at the front in so long, I forgot it existed, and that fuse was blown. It goes directly to the motor power wire for the carriage, and may have blown when I turned it on for the first time while the carriage was still stuck. So I swapped in a new one, and bam! The carriage came to life. I should mention that sometime before this, we'd also discovered that some actions, like line feed and the bell, were working, but actions that tried to move the print head would lock up the logic. But now that it would move, I could see if the rest of the logic would come to life for printing, and it did. This was the first time this machine actually did printing things, and I was so excited. But then...
Oh God! I maybe shouldn't have done that.
I was too caught up in the moment and completely forgot about the stuck pin. The weak signal it was getting before that caused it to heat up a little was now full power. I was not happy, and sure, I just incinerated the coil to the solenoid. But by some miracle, I had caught it in time, and it still measured the same resistance as the other 6. I have a suspicion of what the smoke was, but I will come back to that at the end because it's a slightly risky fix. Now, even though it didn't appear that I fried the solenoid, I had definitely fried my nerves and was relying pretty heavily on my viewers for suggestions on what to do next and being slow and methodical. There are 3 transistors involved in controlling the solenoids. One with the global enable that passes logic through or not, one beefy one that handles the big current, and a middle one that acts as a buffer for the signal logic. We could rule out the global enabled transistor and signals before it because it was activating before when that was still disabled. Measuring the input to the buffer transistor showed that it was being activated, which would always cause the big one to turn on as well. Transistors aren't an on or off device though, and will vary their output based on the input. This is why the signal was weak before and clearly way too much after the carriage was fixed. Some small amount of current was leaking through where it shouldn't. The solenoid control circuits use a mix of positive and negative rails all over. So you see this ground above the transistor? Well, that's actually positive compared to the negative 21 volts the transistor is relative to. So a leak through this capacitor could activate it. That cap was removed and tested fine. The next source of power was behind 4 15-volt Zener diodes that connect to the main 21-volt positive supply for the solenoid. These are a flyback because of the electromagnetic nature of the solenoid. It could generate a voltage spike on its way back that needs to be shunted. However, if the diodes are bad, the high-level rail could leak through and activate the transistor. And indeed, once I measured the diodes, one was leaking. The problem had been found. This diode was always conducting and passing some of what turned out to actually be a minus 24 to 24 volt rail through to the base, causing it to turn on. So I ordered a replacement and just had to wait a little bit more to hopefully fix this thing once and for all.
All right, hello and welcome to day whatever, I don't even know anymore, of working on the DECWriter 2 here. Due to a little mistake on my part, I don't have my big cameras to film here, so we're just going to film hopefully the end of this video with my phone. Maybe I'll finally be free of this, but we'll see. I have Zener diodes in that are hopefully going to be a suitable replacement for this one here that we determined was probably bad. Before we do the replacement of that though, I need to put C1 back here, and I would like to get one final comparative measurement between this section and this section, probably between these, to see what that leakage current voltage drop is, so that when we replace the diode, we can just measure that to see if the head is probably okay before I put the motor carriage fuse back in and let it fully initialize and try and type on it. Hopefully this is the end of this repair, man, because this has just been brutal. All right, C1 just goes here under Q2, and it's getting to be pretty ridiculous that I just know that offhand because these still don't have reference designators. That's just in my brain because I've been working on this for way too long. All right, I'm set up. I'm going to fire this up, and then we're going to measure the voltage on this transistor can and this transistor can to compare them. I believe this one's going to be 18 volts, and that one's going to be 24. Yep, 18 and 24. Okay, now we replace the Zener.
To make a long, dumb story short, I had to cut the diodes off of this because the legs were wrapped around the back of the PCB, and I've been avoiding removing the PCB so I don't have to fatigue the cables that are all very stiff, and I just figured it was a bad idea to try and unplug them all and plug them back in. And unfortunately, when I went to go cut the diode the first time, I missed and crushed the one below the one I was trying to replace, so I ended up replacing two of them.
All right, I've got the replacement diode here. If I measure the voltage drop on that, we can see it's 0.72, and then it rolls underneath of the board. Cool. And on the old one, which does still work, it turns out, if I stick that on there, we can see it's 0.68-ish, depending on how good of a contact I get. So it did still work. But it's very damaged, so yeah, gonna replace it. But I'm also gonna have to cut another one now, since I wasn't anticipating having to replace two of these. All right, let's get these installed. Now, I'm not gonna push the legs all the way through, because I, for one, don't know that this is fully gonna be the solution. And two, I don't want it to poke through to that ribbon cable on the back. I think we turn it on and find out what our voltage is on that transistor. All right, big moment of truth time. Nothing blew up. 24 and 24. Thermal camera, solenoid, let's check it out. Okay, I think I'm recording both the thermal camera and the phone camera at the same time. Man, that's a warm looking phone. So here is the print head, and I'm going to power this on, and we'll see if one of these solenoids gets hotter than the others. So it was the left one that would warm up before. But right now, that's all looking really good. Yeah, I'm the warmest thing here by far. That's looking pretty good. Oh, this might be it. Yeah, it definitely would have overheated compared to the rest of them by now. So I am feeling pretty darn good about this. I'm going to put the fuse back in for the carriage now. All right, it occurs to me there's one more test I did not do, and that is for the dragging pin. So let's turn this on and see if it drags. That is not dragging. Okay. I'm gonna lock that in, and I'm gonna be ready on power here. Let's see if it works. That was weird. Yeah, why is it doing that now? Let me turn off auto line feed. Okay, weird. Okay, I don't know what that was about. Okay. All right, now I'm not surprised I'm not seeing anything because the ribbon is ancient, and I moved the head back. So let me just try that real quick. Yeah, I should probably re-torque the head forward. I forget what the head shim spec was, but I do know that it was basically exactly these two floppy disk labels. So I'm just gonna use these to set the head spacing here. Now again, I'm not surprised that we're not seeing anything. This ribbon is like, not only is it ancient, but you can see one side has been far more used than the other. We can try flipping this ribbon, but I also have a box of new old stock ribbons for this thing for LA36. So let's flip this one first just to see. I'll probably spritz it with some isopropanol or something too, just to get it wet. But yeah, I think this thing's gonna work. Okay, so the ribbon routing on here is pretty easy actually, thankfully. So I'm just gonna take this, I'll take it all the way off here. There we are. Now, flip. And since it goes to the inside, this one goes here. So there's a fork right here. This pulls a thing, and this decides the advancing direction. So if this one runs out, then it's just going to have a little rivet on the ribbon that will get into this, and it'll actually be advancing out this way. It'll pull on this, and that will reset which direction this pulls from. So for right now, we're going to do it here because we're going to be pulling out this way. Okay, so now I'm going to do a light amount of cheating here, and I'm just going to spritz that with some isopropanol, and that should give us some usable ink through that portion. Oh, it is so hard to tell. Yeah, okay. I think we're gonna have to put the new ribbons on. There's a pretty reasonable chance here that I am going to be the first person ever to film unboxing and installing a DECWriter 2 ribbon here. So, brand new ribbon. You can see it's the same. That ribbon is a lot darker than this one is. So, yeah, hopefully this one works out. Let's get this open and installed. Good sign. Did leave some black mark on my finger. Yeah, since this game came from basically government surplus, this might have been the only ribbon this ever had. Ah, there's that rivet I was telling you about, and it has corroded a bit. That's concerning. All right. That's installed now. Let's see if that gets us something to appear in the paper. That's looking a lot better. Okay. Oh, we might be down a pin. Yep, I do think we lost the pin. That is very unfortunate. Ugh. All right, let's see what our alphabet looks like now. It's still very faint, and this is why I don't really use ribbons for this stuff. Wait, the pin is working. It's just weak. Pretty sure it's working. Yeah, it's definitely drawing the top part of the E there. It's just faint. Well, that's difficult to try and diagnose. But hey, it's printing. Good grief, that took forever, but I think it's finally usable. So I can put it back together now that it's not gonna catch fire. Hopefully, maybe. So let me get this thing all buttoned up so that we can try it a little bit more, but then I have bad news. This is a little dirty still. I could clean this, but I want to wait until I can actually use this thing. Ah, there we go. A functional DECWriter 2 Hardcopy terminal. Let me get some paper for it. All right, so right here, there is a slot, and that is where you stick the paper from underneath. The thing is, though, there's nothing else under here. The manual shows you are supposed to put the box of paper just on the floor right where your feet go. There's already not a ton of space in here because that's really close. That's just hilarious. They expect you to have the box right there too. Now this is a two-handed process because you need to be able to feed it in from below and reach the platen control up here once it actually bites to be able to pull it up. Ideally, you get lucky and you can catch it into the teeth in your existing setup and you don't have to do anything, but there's a good chance it won't line up well. But it looks like I got it right there without having to do a whole lot. But here it is all together and ready to go. And we can type on the digital DECWriter 2.
At this point, just to add insult to injury for this video, the outro that I recorded here was corrupted. This is one of the many reasons I don't normally film with my phone. But you aren't missing anything because that's all I can do with it right now, with the only interface it has being 20 milliamp current loop. I'm going to need to find an adapter for it, but those are all super expensive because they are still used for industrial applications. So I might have to try and build one myself. Now I do have one final thing that I'm going to attempt later though. Earlier here, I said that I have a risky fix for the solenoid, and now that the video is over and it's been recorded as at least partially working once, I'm going to try it. There is a chance that the smoke was lubricant burning off of the pin, and it's now no longer able to move freely. I'm going to attempt to flush it with alcohol and re-lubricate it, but the results of that will have to be a second channel video later. I'll link that channel in the description if you want to subscribe there to see when it comes out. This honestly isn't a ploy to get you to go to that channel. I just didn't want to attempt this before ending this video so it could at least end while partially working. Well, that's going to be it for now. I hope you enjoyed this look at the digital DECWriter 2, and if you did, you may want to subscribe to be notified when I release more videos about it. If you want to help support the channel, you can find me on Patreon, but for now, that's it, and I will see you next time.